Hello, my name is Michel Chammas from Lebanon. I'm a PhD student at the University of Franche Comté in France. Our team, Femto-st, from the University of Franche Comté, consists of me and my two supervisors, Professor Abdallah Makhoul and Professor Jacques Demerjian. Thank you for giving us the opportunity to present our work. We are glad to win this competition from our first participation. And also, I would like to thank Professor Vincent Kislane for his kind support during this competition. Well, the competition this year came during the COVID-19 pandemic, so I benefited from the lockdown to allocate a good time for the competition, and the result was very good. So, well, I will start with the competition description. Uh, the competition was very challenging due to many factors, due to the large data set, especially the training data, which was over 100,000 of images, and also around 20,000 for the testing. The competition was very hard. It required a lot of resources and a lot of time. For example, it required more than 600 of gigabyte of memory to compute a PCA algorithm. I will talk more about this during the system description. The development of the system required big effort in terms of time and resources. It consists of the following steps. First, we have for the sampling two main process: extraction of the image patches and the key point using the SIFT algorithm. Also, we label the SIFT descriptor using KNN clustering algorithm. Then, in the feature extraction, we train a CNN model to map the image patches into their corresponding labels. So here we used a ResNet 20 uh, to extract the local descriptor for each document and to create a universal background model. Then, in the encoding process, we generate a global descriptor for each document using VLAD encoding. And finally, in the final step, we compute the similarity using the cosine distance. So in the first step, we extracted the SIFT key point and descriptor, around 128 descriptor for each key point. The importance of SIFT descriptor is that the SIFT is invariant to transformation, scaling, rotation. Then here we used the technique of Vincent that he used in the ICDAR competition, in the ICDAR 2019 competition. We extracted a 32 by 32 patch in the center of each key point of each document. Then we label the SIFT descriptor using the KNN algorithm, and we applied the normalization in order to obtain a compact representation of the data using PCA with whitening in order to reduce the dimensionality from 128 to 32. This reduction helped to decrease the processing cost of the descriptor. Then we used the mini batch k-means for the clustering. So we divided the descriptor into 5,000 cluster with 15,000 each one, to use them as a label for the image patches. Then we trained a convolution neural network. Uh, as we said, we used the ResNet 20 to train the system on the patches. We divided them into we extracted 990,000 of patches, and we divided now them into 90% for training and 10% for testing, which is around 275 batch for each document. Then we extract the local descriptor using the CNN. We used an array of 64 descriptor for each document to create the universal background model. Then we used the UBM was we used k-means to obtain the UBM. The k-means we divided them into 100 centroid. Each centroid consists of 64 descriptor. The total was 6,400 descriptor for each document, for each UBM. Then we used the L2 normalization. And to generate a global descriptor, we used the VLAD for encoding. So as I said before, we aggregated the descriptor into one vector. So we used a multi-VLAD approach. We created 5 codebooks. As I said before, each global descriptor consists of 6,400 descriptor. So we concatenated them, the 5 codebooks, to get a 32,000 dimension global descriptor. And finally, we used the incremental PCA to reduce the size of the vector to 1,600 descriptor, because we used the incremental PCA to solve the memory problem, because the training data set was very large. And in the final step, we compared the document by computing the consign distance. And that's all. At the end, I would like to thank again Vincent for his opportunity to participate in this challenging competition. And we are looking forward for more fruitful and more challenging competition in the coming years. Thank you.